I'm Miranda Sanchez, and this is my project for my computer architecture. This will be just I will talk about the things that we saw in the unit one. Maybe in one moment I will use Spanish because maybe I know some words or the names. Okay, so I will use a notebook to not forget the order of the topics. And to be quickly, because I don't have so much time, to all topics. So first is about the computer history. This started before of Jesus. So why? Because the first instrument, part of the history, is the abaco, which was used to solve simple operations like sum and rest. That was the thing about with the balls. The second is the arithmetic machine. It was a machine in the 1642 built for Pascal. This was a machine to solve sum and less of 0 to 9, but without the need of start to like 1, 2, 3, 4, 5. No, automatically. Second was the Leibniz machine. This was a perfection of the Pascal machine. Why? Because this could make an operation like 1 by 2 or 1 divided 0.2, like that. So that was the difference. We can have 4 operations and not just 2. Instead of that, the difference machine that was made for Charles Babbage. The difference about this is made the 4 simple operations and functions of 2nd and 6th grade. But this 2nd grade was with 6 cifras, and the 6th grade it was with 18 cifras. I don't know how to say cifras in English. Later of that, like before of the computer, was an analytic machine made to also by Charles Babbage. It was a calculadora, but independent. This difference of this have memory and with a arithmetic unit. And this was the first machine with promulgation with programming, but it wasn't made for Charles. Was made for August Ada King. She is like the first programming in the old history, and she made the language programming Ada. Later of this we have the evolution of the electronic with 4 generations: valvulas, transistors, integrated circuits, and the last one is the microchips. Later of this we have the architecture of the computer. This is something complicated because there exist so many of this architecture, but I will talk just about one, maybe one of the most common, and also the Intel and AMD is the von Neumann. The theory about this is a function with 4 principal things: the CPU, the memory, inputs and outputs, and the buses, of bus. Okay, so the processor, the CPU, is about execute operations, and the system of operating to like be like a one form to like talk with the PC. Okay, so this made the operations and technically have the data in a language that is binary. That's like the machine language. Later of this, this have obviously a control unit that have a clock, and this clock is for the unity of time of the process of the data. Later of this we have the memory. This memory was just for storage the information, the data that use the CPU and that moves in the bus. Inputs and outputs is like we saw in the 3rd unit, or the 2nd, I don't know. No, second. In the 2nd unit, about mouse, monitor, headphones, and like that. No, like my mouse. Like example of first input. And last one is the buses. The bus. The bus is it's like that's little things in a master board that likes like the líneas, and this is for move the data. So this was a form that used Newman to not use the cables. Was different to make it easy and to not need so much cables that we use now. It's so much cables. Well, before was more cables. Well, this have so this needs of the data, some because the data is moved. Later the control to organize where go all the data, and the address, this to know where have to go this information. But this architecture could be used at 16, 32, and 64 bits. What does this mean? Well, it's just only about the language. Why? Because originally the PC started with 8 bits. What this means that a data need will have like a cantidad de bits. I don't know how to say it, and this means about the language of that computer have 1 unit. Okay, in that case is the 8 or the 16. The difference about this is if your PC have more bits, like 16 bits, your PC can use a language of 60 bits and a language of 8 bits. The difference is the 16 is more specifically than the 8, and the 32 is more specifically than the 16. So in this way we can say about it's easy for the computer use a way to like how I can say it, to like understand other language less than themselves. Okay, like example, 16 came with 1 of 8 but can't with 1 of 32 because it's so much, is mucho más adelantado. And one of the 64 came with 1, with 32, 16, and 8, and with themselves. But the only thing is maybe they will have a little bit of difficulties to understand all the other because it's less. He needs think more about it, and obviously how this process move it, because here is the RAM, because this the RAM changed with that. Okay, why? Because lo máximo que puede llevar el de 32 son 4 GB, mientras que el de 64 puede llevar hasta 8, pero esto se pueden ir aumentando dependiendo, pero ya depende del procesador que se tenga. Bueno, lo que encontré, lo que entendí, no hay mucha diferencia aquí. Yes, and the time of the operations, because this can change with the nucleus, with the cores. Okay, not in the RAM, in the CPU. Okay, because there could be one of the 2, 4, 6, or 8. Just yeah. I will say another thing over the topic. Later we have the system of numeration system that exists 4. The first is the decimal, that is the first 10 numbers that we use, of 0 to 9. Of this we have the binary, that is just 1 and 0. And we have here some examples about like 1 is 1, 2 is 1 0, the 3 is 1 1, and that's. Later we have the octal, that is of 1 to 8. Yeah, 1 to 8, and here is a move of the 1, 2, 3, 4, 5, 6, 7, and later 10, 11, 12, and that's like we can see. Later we have the hexadecimal, that is just on until the 0 to 9, and later change to a letter. And later we have here hilos, that is the process to start to to execute and to understand what happened in the PC. Okay, are smart programs to make do works. Okay, this helps in the CPU to make the all task in a easy way. Por ejemplo, para hacerlo más rápido, antes solamente había de uno. Entonces era, voy al CPU, me voy, pero el CPU no hace nada en ese tiempo hasta que regrese. Entonces lo que se hizo fue, ok, pongo dos y en lo que va uno, llega el otro, se va, llega el primero, se va, llega el segundo y así van rápido. Entonces se pueden poner dos. Entonces es normal que haya 4, por ejemplo, que son también, son como las buses, que están ahí, son unas líneas, pero están para el CPU. Lo rápido porque ya se me estoy pasando el tiempo. And there we have the planification of algorithms, that is son los que realizan los procesos. Voy a hablar en español porque para ya no atrasarme. Aquí se realizan los procesos de los datos, según lo que lo que hace en el CPU. Bueno, lo que es en el sistema operativo, y el sistema operativo se dice, ok, tú vas al CPU, y así, y va dependiendo. Tenemos aquí una pequeña escala, que es que iniciamos con lo de nuevo, luego que bueno, el estado de un proceso, que son los nuevos, que son cuando se crean, listo, cuando está preparado para el programa, en ejecución, cuando el programa ya se está ejecutando, pero se puede ir en espera, que es cuando se termina y está esperando ya sea a que el usuario haga algo, o que se vaya al monitor, o haga otra cosa. Y de espera se puede ir a listo por decir, ok, pues tengo que esperar porque pues, el usuario ya hizo algo y ahora tengo que irme otra vez a la ejecución, y por último en terminado cuando pues ya terminó. De aquí tenemos unos cuantos que son el first come first served, que es que tomará primero, el primero que venga, el primero que se ejecuta y así. Entonces así, uno corto, vamos, uno largo, ok, me tarda un poquito, uno mediano, ok, va. El segundo es el más corto, va a trabajar primero. Aquí va a tomar los más cortos, los ejecuta una vez y así se va rápidamente. El problema es de que los más largos los deja al final, entonces puede tardar un poco más. Luego están los del radio, siguen los de radio más grandes puesta, Highest Response Radio Next, que es de que aquí básicamente hace una división con el tiempo de espera del CPU más el servicio del programa más entre el propio servicio. Saca el radio de respuesta, el que tenga la respuesta más corta, agarra primero. Y así lo va agarrando entre los procesos. Luego tenemos los expropiatorios, que aquí tenemos por ejemplo el round robin, que es los procesos les asigna un tiempo y los va procesando así en orden. Así de, ok, tú tienes un tiempo, ok, no te terminé, ok, te vas a esperar, te vas al final, ahora tú, no terminaste, te vas para acá. Tú, en tu tiempo lo terminé, ok, bye. Y así se va. Y va en orden, y los procesos más largos suelen hacer un ciclo. Y luego está el del menor tiempo de respuesta, ¿ok? Que también es explotativo. De que se procesa primero que tengan del menor al mayor. El problema de esto es de que es como el de corto. Entonces, si requiere a los que tienen mayor, pues va a estar hasta el final. Y pues bueno, este fue mi resumen. Me pidió muy poco tiempo, por eso a los últimos temas los hice muy rápido. Una disculpa.